videos. طيب بسم الله الرحمن الرحيم. So this is about chapter 5 CPU scheduling. There's a lot of concepts, a lot of stuff here in this chapter, but now I will focus on simple um, methodologies or algorithms for to explain how would the CPU execute multiple processes. So this is a simple question. So it means how, okay, the OS use the CPU to execute multiple processes, okay, within a defined schedule. Okay, so this is the major thing in simple terms. So this is what we are going to learn. So we will see multiple ways to do it. So we have, as you remember from last lectures, every application, every operating system command, oh, they need to be executed by the CPU. So the operating system have to make a schedule and order these processes so that the CPU can do it one by one. Okay. The CPU, one CPU cannot run many processes in one single moment. Type it cannot. So how the CPU will do? So he have to have some schedule, and this schedule the operating system control in different ways. One way to do it is something called the first come first served. First come first served. So this is the first way. Second way is something called uh, the shortest job first, SJF. And then the third thing is we have something called the round robin method. So these are the three ways, three methodologies. It's not the only three, but today we will talk about these three, and there are a lot of others actually. Okay, so we will explain this, but generally, every one of them, it's a way so that the CPU execute the processes. Okay, so we'll start with the first one by examples. Maybe this will be more clear for you. Okay, so the first one we have is the first come first served method. As an example, we have a list of processes. Okay, so we have process 1, we have process 2, and we have, for example, process 3, and all these processes, they already ordered. يعني this one will be the first one, and then this is the second one, and then this is the last one. So the CPU will have them in priority ordered. Okay, so they have their own order already. This is the order 1, 2, 3. So this one will be executed first, and this one, and this one. So it's like this, top down. So they are like in a queue, okay, waiting, so that to be executed, and then P1 will be executed first, then P2, then P3, right? And we have time for completion. The time for completion, we call it burst time. We call it the burst time. Burst time, if you look into it as a definition, it is how much the CPU need to execute one process. How much time needed by the CPU to execute this one or this one or this one. So we'll suppose that this P1, it needs, for example, 15 millisecond, and this one 7 milliseconds, and this one 10 milliseconds, right? So the schedule here, this is the schedule. The operating system will create this schedule and then convert it into something called a Gantt chart. And the Gantt chart simply is a simple table that will show you the time. It will show you the time, and from the time you will know what is going, you will know which process will be executed first and which is the next one. So as I was saying, it is a queue. It is a queue. So the first process, P1, it will be executed at the beginning. So we will consider time 0, the first يعني millisecond, يعني in millisecond 0, P1 will be executed. How much P1 need from the CPU? It needs 15 milliseconds. So it will continue 1, 2, 3, 4, 5, 6, 7 until 15. So by 15 milliseconds, process 1 will finish execution inside the CPU. So the CPU will be busy executing P1 from 0 millisecond to 15 millisecond. He's busy executing P1. He's not doing anything else. The CPU is busy only executing one process. The second process here, P2, it requires 7 milliseconds. So the CPU will after finishing P1, he will start executing P2 from 15 milliseconds in time plus 7 milliseconds, okay? He will finish it in 22 milliseconds. So from 15 to 22, this is 7. From here to here, this is 7 milliseconds. This is how much time is required to complete process 2. Okay. طيب. And so on. We go for the third one, P3. P3 requires 10 milliseconds. So from 22, we will move 10 until we reach 22 plus 10 is 32 milliseconds. In this way, we are ordering the tasks for the CPU. Okay, sometime they say tasks, it is the same as jobs, it is the same as processes to be executed by the CPU. Don't get confused with the different words. It's all meaning the same thing. Okay. So this is one way. So the operating system, he he has a program, part of the operating system. Yani, this program uh, will arrange processes P1, P2, P3 in order, and then he will send a system call for the CPU to execute P1. After finishing P1, he will send P2. The operating system will request the CPU to execute P2, and then a third request to execute P3, and so forth, and so on. So this methodology, this way, this algorithm, they call it first come, first served. So P1 came at first, we serve it first. Who serve it exactly? The CPU. The CPU is the service provider. Okay, so he will execute P1, he finished the service for P1, and then he go serving P2, and then finish and go serving P3 in order. So this is called first come first serve algorithm or methodology. طيب. The second way, and the second way we have first come first served plus different arrival times. يعني the processes are not in order, are not in order. طيب. In this methodology, if you notice, all the processes here are in order. All of them are in order. The order is known. We know the order. This way, we have processes, but their arrival time is different. So, example, we have processes. For example, process P1, P2, and P3, and P4. And for every process, we have arrival time. So they arrive in different times. They arrive in different times. Here in this example, the one before, we are like Allahumma salli Muhammad. What do you call it? We suppose, okay, that all processes are available at time 0. خلاص كلهم موجودة. All of them are available. This is what we suppose here. Okay, and we have them already, and we already put them in order. Here in this example, we suppose that the processes might arrive in at different times. So for example, P1 arrive at time 0. So this is the first one arrives, but P2 arrived at time 4 for 4 milliseconds, and P3 arrived at time 2. Okay, and P4 arrived at, for example, time 1. Right. How much time it need for execution? We call this the burst, okay, time. So burst, this is how much time needed by the CPU to execute the process. So we'll consider 5, for example, here 7, and here 3, and here 10. Okay. Now, the operating system, he will create a Gantt chart in order to show which process will be executed first in a queue. Right? In a queue. So the first one in the Gantt chart, okay, at moment 0, which one came at moment 0? P1 came at moment 0. So we have P1. How much time P1 needed? It needs 5 milliseconds for execution. Which process is next? It's not P2 and not P3, because they arrived at 4 and 2, at time 4 and time 2. The next after P1 is P4, because it arrived after 0, 1 directly. So you will rearrange according to the time of arrival. So P4 came, and P4 time is 10 milliseconds. Okay. So 15 plus 10 is 15 millisecond, and after that in order we have process 3, it arrived at time 2. So this is in priority now. Priority here P3, and P3 requires 3 milliseconds. So it will stop here. 15 plus 3, 15, 16, 17, 18. So it will finish at time 18. And the last one is we have P2. The last one arrived. So we serve it at last. So we serve P2, or the CPU will serve P2. Okay, and the CPU requires 7 milliseconds for execution. 18 plus 7, this is 25. So in this sense, we have ordered all the processes. We ordered all the processes according to the priority of arrival time. So the arrival time give us the priority, which one to serve first. So we have first come, first served, but according to time. So our priority, our order is the time of arrival. Right? Okay. The another way to do it, number 3, we have something called the uh, uh, اللهم صل على سيدنا محمد, shortest job first. Okay, SJF. Right. What does that mean? A job is a task or a process to be executed by the CPU. This is the job. And on what basis we order the jobs? We order the jobs not according to time. We order the jobs according to the uh, we order the jobs according to or from the shortest time to the longest. What we mean by shortest? So shortest execution time to the longest execution time. Okay, so the our priority here, this is the priority. Our priority is not time of arrival. We don't care what time they arrive. We don't, like before here, this first come first serve. If it comes early, we serve it early. So this is the according to the order of time. Here, no, we don't order according to time, according to arrival time. We order it by how much time needed for execution. So if it is the shortest time of execution, this is our priority. This is what we select first. And if the job is big, large, long in execution time, it will keep the CPU too much time busy for a long time. We don't execute it at the beginning. No, we leave it to the last. Okay, so our priority here on how much time of execution the time. So for example, we have uh, process P1, P2, and P3 here. Okay, so arrival time, we don't care about arrival time, regardless of arrival time. How much time needed by the CPU for execution? This is the burst time. This is what we care about. So this is 4, this is 10, and this is 1. So we don't care about when it did come. No, we care about how much time it will keep the CPU busy. So the smallest one, the shortest in time, this is our priority. So our priority hit this one first, and then this one, but then this one. So because this will take less time, we will start with this one, right? So this is the strategy the CPU, the operating system will follow. So the Gantt chart will look like this. At time 0, we will select which one, P1, P2, P3, which one we will select. We will select the one with the least or smallest or shortest in time. So this is the first one. This is the one is less than 4 and 10. So we select P1, P3. Okay. How much time P3 require? It require only 1 millisecond. So we finish it early. خلاص مع السلامة. Okay. The next one is P1. Okay. How much time it requires? P1 needed 4 milliseconds. So 1 plus 4, it will finish by millisecond 5. Then the last one will be the longest in turn in execution time. P2, how much time it needs? It needs 10. So 5 plus 10, 15, and it will stop here. Okay. So this is the methodology here, or the algorithm, shortest job first. Shortest job first. So it is executed according the order and the priority here, priority based on this one, on how much I'm going to keep the CPU busy. So I don't want to keep the CPU busy for a long time. My priority is give the CPU the easy jobs, the shortest in time jobs. He finish it early. Okay. If the job is very big, no, don't do it at the beginning. No, delay it. You will execute it later. Right? So this is a second, a next methodology, a simple one also. Number 4 here, we have something called round robin, RR, round robin. And round robin here, Robin said, we will make the CPU running processes in rounds. In rounds. And what does rounds mean? In rounds, it means the CPU will serve all processes in the queue in one round for a specific limited time. So the CPU will serve all processes, all waiting processes, type, with a limited time, even if they needed more. Right? So this is the methodology. If we have 100 processes, so the CPU will serve the all 100 processes. They will serve them for a very limited time. For example, 2 milliseconds for everyone. خلاص 2 milliseconds for if all processes in one round he finish, and then he go again for the uh, processes, and he will serve them for another 2 milliseconds for 2 seconds, and then for the next round he will go again and serve all processes for another 2 milliseconds. Some of the processes are short, they finish early. Some of the processes are long, they finish later. So this is the point of or the logic out of the round robin. An example to be more clear about it. So I'd rather describe round robin is like it's first come, first served plus a quantum. Quantum يعني limited time. يعني we with a time limited service time. Okay, so if I am a manager and I want to visit all employees, I don't spend much time in too much time for every employee. No, I give for all employees 2 minutes. If you finish your business in 2 minutes, fine. If you don't finish it, come to me later. So I give only very limited time for all employees equally. So the logic here that all the priority here, the priority is not defined. There's no priority here. We don't give priority of who come first. We serve him. Uh, no, I will delete this. Okay, we'll say that all processes have or طيب processes plural. This the English people will catch me on this. طيب have the all processes have the same priority. They have all the same priority. Right? But I will serve. But who comes first is served first. Okay, so this is the point. So we have a kind of order. So we have an order, but at the end they are all of the same priority, and I give them the same amount of time. Okay. طيب, anyhow, the example we have the processes here. Suppose we have P1, P2, P3, and P4, and we have here the burst time. How much time B1 need for execution? We will say, for example, it needs 12, and this needs 10, this needs 15, and this needs 2. Right. What is the priority here? We already have the order top down. This is our the order. What is it? And this is how we have the order, and all of them, they will give the same amount of time. For example, in our example here, we will say, okay, the CPU will serve every process for 5 milliseconds. So this one we call it a quantum. Okay, so the quantum is a specific period of time that the CPU will execute the process. So this is the same time for all processes. So what will happen is then, so we have round 0, round 1, and so forth until we finish. So in round 0, the first round, the CPU will go and execute for 5 milliseconds for this process, and then this process, and this process. 5, 5, 5, 5, 5. So he will give 5 here, 5 here, 5 here, okay, and 5 here. So from the 12 will split into 5 in the first round, but it is not over. So it need another 5 in the second round, and in the third round it needs another 2. So 5, 5, 2 is 12. 10 in the first round, the CPU will execute. It will finish only 5, half of it, 5, but it will be finished totally at the round number 1. Processor 3 is 15, so it needs 5, 5, 5. It will not finish until it reaches the third round. Process 4 is very small in amount of time, so it will be finished in the first round, in round 0, R0. So it will finish, it need only 2, right? So this is how we split يعني the CPU. So who was managing all of this? The operating system. So the operating system, part of the operating system, there is a software, a scheduler software, and this software will schedule the processes of the available for execution. He will order them in this way, and then he will split them and make the CPU busy for 5 milliseconds in the first round 0 for all processes here. Until he finish, he go here and keep the CPU busy, and then the CPU here will be the least busy. So in R0, the CPU is mostly busy, R1 less busy, R3 the least busy. Uh, and here, if you go to round 4, for example, there are no processes, nothing there to process. So the CPU will be idle. Okay, he not doing nothing. Right. Okay, I hope everything is clear. If you have any questions, you can always put it in the chat. Right. Now we want to create the Gantt chart. Okay. In the Gantt chart, we what is which one will we will start with? The in Gantt chart, it depends on the order here, from top down. In round robin here, خلاص, the order is defined: P1, then P2, then P3, then P4, top down. That's it. Okay. There's no specific arrival time. We consider that this one is first, and then this one, and this one, and this one. Right. So we have whatever this one. Okay. Right. So the at time 0, P1 will be executed, and then P2, P3, P4. So this is round 0. All of them are going to be executed. P1, P2, P3, and P4. This is the first round. P1, P2, P3, P4. So the CPU will go for all of them. All of them are there. All of them need time. This one, this process P1, he will execute only 5 milliseconds. So the remaining 7 here, okay, 5 and 2. P2, he will execute 5 and remaining 5. P3, he will execute 5 and remaining 10. P4, he will execute 2 and finish it. Okay. And so this is the order. This is the first round. So we'll put all the processes in the first round, and we see how much time. So P1 is 5. Okay. This is 5. P2 again 5. So 5 and 5 is 10. P3 also 5. So this is 15. And P4 is 2. So it will stop at 70. So the first round R0 will finish by the millisecond 17. The next round here is R1. So again, we will go running all processes again. So we will have 3 processes left. P4 finished خلاص from the first round. This is over خلاص. We finished it. So nothing is here. So we remaining are 3 processes: P1, P2, P3. So we have P1, P2, P3 still need more time from the CPU. P1 it need 5 P1. We need 5. So this is 5 for P1, another 5 for P2. Oh, sorry. It needs 5. يعني at the time 17, we add 5 to it. So to complete P1. So the total is 22. And then P2 again, another 5 for process 2, another 5. So it will be 27. The last one here in the second round or round 0, round 1. In round 1, the last one here is P3 with 5 milliseconds. So the total will be uh, 27 plus 5, 32, 32. Okay. Bye. Now this is the R1 round. It's done. خلاص. What is remaining? Remaining in the last round, we have only two processes remaining, P1 and P3, not yet finished. P1 and P3. So P1 needed only 2, so we add 234, 32, we add plus 2, so we will stop at millisecond 34 to finish the last part of P1. And we have P3, process 3, it requires 5 milliseconds to get it completed by the CPU. So 34 plus 5, this is 39. 39. So at millisecond 39, the CPU will complete all processes. Right? So this is the way of scheduling um, using the techniques first come first served and the shortest job first and round robin. It's not only these three techniques, there are a lot of many other things, uh, but I don't want you to get much complex things up to now. This is enough for today. طيب. Um, Inshallah ta'ala, in next class after vacations, we will, inshallah ta'ala, explain more on these techniques and to compare which technique is better. And there are some calculations, not difficult calculations, average and adding numbers like this, to compare which methodology is better, how we can best utilize the CPU, what are the scenarios available, uh, what are the advantages, disadvantages of these methodologies. Inshallah ta'ala, we try to cover by next class. For today's class, we are done, alhamdulillah. As a reminder, just please try to fill your attendance here. Okay. And also there is an individual task. As I told you, every one of you try to do it. Please do this individual task in order to have an idea about messaging. Okay, a better idea about messaging. See you inshallah by after vacations. Hope best wishes for everyone. And Assalamu alaikum wa rahmatullahi wa barakatuhu.